is Miss Beatenbow, and in this video we are going to cover our geometric transformations focusing on rotations, which is where we are turning the object. Now, a couple things in our terminology we want to make sure we remember. When we are mathematically transforming an object, we're somehow changing something about it. Our original figure is what we're going to refer to as our pre-image, and the image actually is the transform figure, the new location, and you can tell the difference between the pre-image and the image when they are plotted because the image, the new location, is plotted using primes. So point A on the original pre-image would be A prime on the new image after the transformation has been applied. With rotations, this is a type of transformation where a figure is turning around a fixed point, which is the center of rotation. There is no change in the shape or the size. Since there is no change, the images and the pre-image will be congruent. So, same size, same measures. We are going to have a different orientation, more than likely, though, from the image compared to the pre-image because we are turning it. So it kind of makes sense if we turn it that more than likely the orientation is going to be a little bit different. And you're going to notice that the points are going to be named in a different order if we look at it depending on how far it's turned. But it still is congruent even though we have taken and turned that. When we are doing our rotations, we can rotate. We can turn it clockwise or counterclockwise. It's important to remember clockwise is going to be going and turning it this way. Counterclockwise, we're going to be turning it the other direction. I know we live in a digital age, so we don't have second hands everywhere, but even if you just add it to your notes to make sure that you know which one's which. A 360-degree rotation, remember there are 360 degrees in a circle, is when we go from the start all the way around, and it will result in it being in the exact same position as we started. When we're talking about our centers of rotation, we actually can rotate around any possible point. So even though in this course we're always going to be rotating about the origin, that 0, 0 point, it is possible to rotate around other points. We're just not going to go and do that in this course, but just so you know, it can be done. So just like our other transformations of our reflections, there are specific rules for each precise type of rotation. So if we have a 90-degree clockwise rotation, we're going to be going 90 degrees clockwise from our pre-image, and it should result somewhere in that direction. So we're going to follow our rule. And if you notice here, we are not only switching where the coordinates are, but one of them is becoming negative. And we're changing the sign. So what was our y value in our point 2, 1 is now going to be our x value. So 1 will be our x value. What was our x value is going to have a change of sign. So it's going to become negative, and then whatever the original x value was, which was 2, so negative 2. So our A prime location is going to be at 1, negative 2. And here, pay attention to our grid, because if we notice, it's by 2's. So 1, negative 2 would be right here for A prime. If I were to draw from here to here, you will notice that that is a 90-degree angle. So we have rotated it 90 degrees clockwise, A to A prime. Now's a good time to pause this, Go work out B prime and C prime on your own and then restart it to check your answers. So as you work through B prime and C prime, you may have noticed that our original x values were negative. So when we have our negative x value, that negative is going to cancel and give us just a positive. So our B prime location is going to be at 4, 6, and our C prime location ended up being at -2, 3. We can go and connect those points and find our image location. Looking at it, you can see that it definitely does appear congruent to what we started with, but there is a definite orientation change. We have rotated that object 90 degrees clockwise to find our new image location. We can also do the same thing going counterclockwise. So here we're going to go 90 degrees counterclockwise, turning it the opposite direction. We are, if you notice, going from x comma y to -y comma x. So we are switching our location of our coordinates, but this time it is the new x value that comes from our previous y value becoming negative. So we have 2, 1. Our previous y value will be negative. So we'll have -1. And then our new y value is what was our x value, which is just going to be 2. So we have a prime at -1, 2. Go ahead and pause this video and take some time to work out B prime and C prime on your own and then restart it to check your answers. So when we went through this, we noticed that our B prime, we just ended up with the -4, -6. The negative from -6 is going to stay because in the rule there's no change with the new y value of the sign. When we got to C prime, we had to make sure that we did our -2 was then made negative, those two negatives canceling, giving us that +2, -3. So again, we can plot our line segments, connecting them, and we see again A prime, B prime, C prime is congruent, but in a different orientation because we have done that 90-degree counterclockwise rotation. The final rule for rotations that we are going to have you remember is 180 degrees. Now, the interesting thing with 180 degrees, well, there are 360 degrees in a circle. So if we go 180 degrees clockwise or 180 degrees counterclockwise, it will result in the same position. So you actually will not be told clockwise or counterclockwise because either way, it will result in the same image. So we are going to keep our x and y coordinates where they are, but they both are going to become negative. So 2, 1 will just become -2, -1. Which would plot to right there for our A prime. Go ahead and take a minute, pause this video, work out where B prime and C prime will go following this rule, and then restart it to check your answers. Again, here I am sure that you noticed that we're having negatives. So some things that were negative will now be positives. B prime will be located at 6, -4. And with C, both of them were negative, so the negatives cancel to positives. So C prime is at 3, 2. We can draw out our triangle, and again noticing that is congruent to what we started with. Definitely different orientation. And we have gone 180 degrees halfway around our circle. So now that you know how to use the different rules of rotations, we also need to look at symmetry. When we have a figure, sometimes we can divide it in half so that one side is exactly congruent with the other side. Some figures will only have one line of symmetry. Other figures will have multiple lines of symmetry. So, for example, this rectangle here, I can divide it down the center vertically and get the left half and the right half being congruent, or I can divide it across the middle horizontally where the top is congruent to the bottom. We can also find rotational symmetry, which is where we have a figure, we're going to turn it around the center point, and as we turn it, that image is going to look like the pre-image we started with. So if we use our snowflake here, and we're going to say we start at the top, if I were to turn this top part of the snowflake this way all the way to here, at this point I have one turn to where it's going to look exactly like the same orientation. And so this is going to help us find our order of rotation, which is the number of times we can rotate this image to look like the pre-image that we started with. So if we keep going and we notice that if every time we turn it, we stop where one of the ends of the snowflake was, and we keep going all the way around to back where we started, I can turn this 6 times before this particular part of the snowflake would end up all the way back where it started at the top. So in this case, our order of rotation for this snowflake is 6. To find that angle of rotation, which is the degrees that we must rotate this around the center in order for it to look like itself, we're going to take 360 degrees, so the total number of degrees to where it was back exactly where it started, with that top one being back on top, and we're just going to divide it by the angle of rotation. So 360 divided by 6 is going to give us 60 degrees. So here, the angle of rotation for this snowflake is 60 degrees. So every time I rotate it 60 degrees around the center, it is going to look exactly like it did before. And I can do that a total of 6 times the order of rotation before it's back where it started. So I hope you definitely have a better understanding of rotations now. We know how to find the angle of rotation. We are definitely able to talk about rotations in terms of angles and circles and how we're turning it about a certain portion of the circle. We should be able to draw those lines of symmetry to divide our objects specifically in half. Using the rules, you can identify rotational symmetry. Whatever rule fits will be what rotation is taking place. And if we have those rules, both from here and from the previous ones, especially our reflections, we'll be able to use individual rules time after time to find out which set of sequences would get our object exactly back where it started. And it might be a little tedious. You are going to have to do several different transformation rules, but you will eventually find the one that locates that point exactly back where it started by following that sequence. I hope this did help you and that you have a much better understanding of all of your transformations now.